thought today I'd bring you right back to the classroom. So welcome back to my classroom. And so we'll do the lesson. I might have to break it down into 2 videos because I have part of my board, one part of the lesson, the other, but we'll figure it out, okay? So if you think back to yesterday we talked about what to do whenever you have a sequence that's what's called finite. In other words, like if you look at this problem, number 1, a finite sequence would not have this part right here. So if it's a finite sequence, then that means that you can either just write out the terms, however many terms they want you to add up, and you just simply add them. Or we had 2 formulas that you can use if it was arithmetic or geometric. 2 formulas you could use that will add it up for you, okay? So now today, what we're talking about is what to do when they ask you to find the sum of an infinite series. So remember, series just means that you're adding up the terms in the sequence, okay? But the infinite part is the part that's a little different. And that's the reason why you have these little dot, dot, dots here. So if the sequence keeps going, in other words, they want you to actually keep adding it up, how do you answer that question whenever they say, what is the sum of that sequence? Well, that's what we're talking about today, okay? And so I kind of wrote down 3 sequences so that you could kind of observe what goes on when you start adding up these sequences. So that's what I'm going to show you is what do we get, or what happens when we start adding up a sequence. And then we're going to look at the sums, like what do we get when we actually add up the sequence, okay? So it might involve us having to continue the sequence a little bit, okay? So like with this first one, if I wanted to continue the sequence, I'm going to have to figure out the pattern. So what am I doing to 1 to get 3? What am I doing to 3 to get 9? 9 to get 27. And so you can kind of go through a couple things of reasoning, like am I adding a number? So what do I add to 1 to get 3? I'd have to add 2. So if I add 2 again, I won't get 9. So that means it's not arithmetic, so then see if it's geometric. What do I multiply 1 by to get 3? And if I take 1 and I multiply it by 3, that'll give me 3. If I take 3 times 3, that'll give me 9. 9 times 3 is 27. So the pattern here is that I'm multiplying by 3. So if I want to continue this, so I'm going to erase this. If I continue this, then I'd have to take 27 and multiply it by 3. And so let me figure out what that would end up being so I make sure I don't make a mistake. That would be 81. And then you could multiply that by 3 again. So if I multiply that by 3, that would be 243. And then we could keep going. So you can extend this however long you need to, okay? But then we're looking at what happens when we start adding up the sequence. What happens to the sums? So now I'm going to actually start adding it up and see what's going on. And just kind of make an observation about the sums. So when I start adding up this sequence, 1, it's just 1. But then when I take 1 plus 3, I get 4. When I take 1 plus 3 plus 9, so I'd take 4 plus another 9, that would be 13. Plus, if I add in that 27, so in other words, 1 plus 3 plus 9 plus 27, that would give me 40. And then I would keep adding. So 40 plus the next term, 81, that would be 121. And then if I take that, so let's see, plus the 243, which I could do that, but just want to make sure I don't make a mistake again. You get 364, and then again, if you continued it, you would keep getting the sums. And so what's happening as we add more and more in? Well, it looks like it's just getting bigger. So as of this moment right now, I just want you to kind of notice that the sums are getting bigger. So we'll put sums get bigger. Okay, so now let's observe this one. All right. So I'm going to do the same kind of thing. I'm going to write out some of my terms, but I have to find the pattern first. So what am I doing to 1/2 to get 1/4? What am I doing to 1/4 to get 1/8? And you can go through the same reasoning. Am I adding a constant number? Am I subtracting a constant number? Am I multiplying by a constant number? And so when I look at this, I'm noticing that if I take 1/2 times 1/2, I actually end up getting 1/4. If I take 1/4 times 1/2, I get 1/8. 1/8 times 1/2, I get 1/16. So what's going on is we are actually multiplying by 1/2 here, okay? So to keep this going, I'm going to continue that pattern. So 1/16 times 1/2, I get 1/32 or 1/32. If I take that and I multiply that times 1/2, I get 2 times 32 is 64. And then I can keep going. 1/64 times 1/2. 1 times 1 is 1. 2 times 64, that would be 128. And then obviously we could keep going. We could just keep multiplying by 1/2, okay? So now I'm going to do the same thing, and I'm going to look at what's going on when I start adding up these terms. And instead of writing the fractions, it's actually more beneficial for this observation to look at the decimals. So I'm going to show you what the decimals look like whenever we start adding this one up. So if I take 1/2 plus 1/4, you get 3/4, which is essentially 0.75. And then if I add in my 1/8, you get 0.875. And if notice I'm taking, and actually the first one would technically be 1/2, so that'd be 0.5, and then I added those two, that's where the 0.75 came from. Then I added these 3, that's where that one came from, and now I'm going to add in my 1/16. So I get 0.9375, and then I'm going to add in my 1/32. So that's 0.96875. And then I'm going to add in my 1/64. Oh goodness, these decimals are getting ridiculous. So 0.98435. And I'm going to add in the last one that I had found so far. So 0.9921875. And now this would be one that it might actually be beneficial to continue it to see what happens when you start adding more and more. But I will go ahead and kind of tell you, if you continued this sequence and added in more terms, what's going to happen is it's going to eventually get to where you have 0.999 something something something, then 0.9999. So what happens is it starts getting closer to like 0.999999999. And so what's actually going on is this is actually going to start getting close to 1. And so this is a special type of series. So the sums in this problem actually get close to 1. Okay, so that's going to be a special type of series that we will mention in a little bit. All right, so then the last one is also kind of a different one. I've lost my cap, so let me find my cap here. So this one, we're going to do the same thing. We're going to extend the sequence a little bit and then look at the sums. So this one, got to find the pattern. And this one actually is a little bit easier to find the pattern because you could probably quickly notice that you're just simply adding 2. So like 3 plus 2 gives me 5. 5 plus 2 again gives me 7. And so the pattern is actually arithmetic, okay? And so we're going to continue that pattern. So if I take 9 and I add 2, that gives me 11. If I take 11 plus 2 again, that gives me 13. Oh. If I take 13 plus 2, 15. 15 plus 2, 17, and then again, we could keep going, all right? So we're gonna do the same thing. Let's see what happens when we start adding up this sequence. So let me grab a different marker here. So 3, if I add that, it's just 3. And then if I take 3 plus 5, that's 8. And if I take 3 plus 5 plus 7, that would be 15. And then if I add in my 9, that gives me 24. And then 24, so that was all of these. And then if I add in my 11 to all that, that would be 35. 35 plus the 13, that would be 48. And then if I take the 48 plus the 15, that would give me, let's see, 62, I believe. Let me just double check because being recorded really throws me off. So I apologize, you guys. Oh, I was 1 off. Let me make sure, yep, 63. I don't know where I got off with that one. And then if I take 63, and I add 17 into the mix, so that would be 70. And so then you could, again, keep going as long as you extended the sequence. So let's look at the sums here and look at what's going on. So these, kind of unlike the problem that we just saw, these seem to be just getting bigger and bigger, as just like this one did. Okay, you will notice that there is a bit of a difference, but the sums for this one get bigger. Okay, now I do want you to realize with this one, there is a reason why they're getting bigger. Think about what's happening in the pattern. They're just adding to. And so it's always going to be getting, like the next term in the sequence itself will be getting bigger by 2. So, you know, when we add in, it's going to be getting bigger by 2 plus that extra term. So that's why it's getting bigger. If we were subtracting a number, it would actually make it get bigger in a negative sense. So like it would go into the bigger negative numbers if we were subtracting a number, okay? And so just keep that in mind, all right? So before we end this video, I want to talk about what's going on in terms of the terminology that you have to know. So some of these sequences did what's called diverge, and then some of them converged, okay? So diverge means that when you start adding up the sequence, in other words, they call that partial sums when you add up part of a sequence. So if the partial sums, when you start adding it up, approach infinity, in other words, it keeps getting bigger and bigger and bigger, or bigger in a negative sense, or you can think of it, or does not get close to a number, then it diverges, okay? And so with these sequences, you can think of them as they have no what's called finite limit. They have no limit to what their sums will be, okay? They're either going to keep getting bigger and bigger and bigger, or they're going to get bigger in a negative sense, okay? So now converge is a different type of sum. So if you start adding them up, and they actually, the partial sums, when you start adding up part of the sequence, if it actually gets close to a number, then you are saying that it converges, okay? So this would be if the partial sums get close to a certain number. And now the thing you need to realize about that is when something converges, then it's going to get really close to it, but it actually never really gets there, okay? Which is a very strange concept, but that's what it means to converge, is it's going to get really close to a certain number, but it'll never actually get there. And so with these, they would say that these sequences, when you start adding them up, they have a finite limit. So this has a finite limit because there is a limit to it, kind of like the speed limit. You know, you've got a limit, and technically you're not supposed to pass that limit, okay? So that's the difference between converge and diverge. So if you look back at your sequences, the first sequence and the third sequence diverge because when we start adding up the sequence, they were getting bigger and bigger and bigger. They didn't really have a limit to them. But if you look at number 2, it was getting really, really close to 1, but it never actually gets there, okay? And you can test this out. You can start writing out the sequence even more, and you'll notice that, like I said, it'll get really, really close to 1, but it'll never actually reach 1, okay? So number 2, that sequence number 2 actually converges. And when it converges, the correct way to say it, instead of saying it like this, is you would say that this converges to, and then you have to tell me what number it gets really close to. So this one converges to 1. This one, because it diverged, you just simply say that it diverges. And then same thing here, because this one kept getting bigger and bigger and did not have a limit, you would say it diverges. So that's the correct answer to those problems.